Alright, exercise 1.2a, question 6. The roots of the cubic equation z cubed minus 2z plus 4 equals 0 are alpha, beta, and gamma. Find the equations of the cubic with roots, and then in part A, alpha squared, beta squared, and gamma squared. You can actually go about this in a couple of ways. You can consider alpha plus beta plus gamma squared equals alpha squared plus beta squared plus gamma squared minus 2, and then the sum of alpha beta. So you could go ahead and do it this way using algebra, but I'm going to do it using substitution. So you can take any one of these letters, it doesn't matter which one. I'm going to take alpha, for example, and then end up with something about alpha squared. So we know that since alpha is a root of this cubic equation here, we have alpha cubed minus 2 times alpha plus 4 equals 0. And so factoring out alpha there, we have that alpha times alpha squared minus 2 is equal to negative 4. And then from there we can just square both sides. We get alpha squared times alpha squared minus 2 squared is equal to positive 16. And from there, if we let y equal alpha squared, we get y times y minus 2 squared is equal to 16. And then just expanding that thing out, we get y times y squared minus 4y plus 4 equals 16. And then so finally, y cubed minus 4y squared plus 4y minus 16 equals 0. So that is our final answer there. And since there was nothing special about alpha in this context, what we did also works with beta and gamma, since they make this equation true, and no other values make this equation true, since there are only 3 roots of this equation. We have that y equals alpha squared, beta squared, or gamma squared is a solution of this equation here. Okay, moving on to part B. If we consider 1 over z and put it into the polynomial, then we get 1 over z cubed minus 2 times 1 over z plus 4 equals 0, and clearly z equals 1 over alpha, 1 over beta, or 1 over gamma are solutions to this thing. Okay, so we got 1 over z cubed minus 2 over z plus 4 equals 0, and then we can get a cubic equation with the appropriate roots by simply multiplying both sides of the equation by z cubed. So we get 4z cubed minus 2z squared plus 1 equals 0. And that's our answer for part B. Okay, and for the third one, part C, we can make the observation that the roots of the polynomial we're looking for here are the squares of the roots of the polynomial that we just previously found. So we can do something similar to what we did in part A. So let's let y equal z squared, and well, let's keep all the odd powers on one side and the even powers on the other. There's 2 even powers. Remember, this is a z to the power of 0, so that also counts as an even power. Alright, so let's so we got 4z cubed equals 2z squared minus 1. Okay, now we want to end up with even powers everywhere, so let's go ahead and square both sides. So we get 16z to the power of 6 is equal to 2z squared minus 1. Things are looking great because z to the power of 6 is just y to the power of 3. So that gives us 16y to the power of 3 is equal to, and I forgot to square the other side, is equal to 2y minus 1 squared. And so we get 16y cubed is equal to 4y squared minus 4y plus 1. And finally 16y cubed minus 4y squared plus 4y minus 1 equals 0. And so that's our answer to part C.